You guys all watched the layering video? Watch the raise your hand. You watch? I know you have to be fine, that's I'm coming to you.
No, she said the history.
You guys watched for the layering?
Oh, yes.
Who watched? Raise your hand. You're walking my. It's a problem. It's okay. It's over?
No, it's the video. I watch videos. The layered videos.
That's chapter 2. We still, for chapter 1, we still have a tail.
Oh, yes.
I'm amazed. Okay, let's watch. If you haven't signed, please sign. Then I will get the classroom back, okay? If you check this, chapter 1 is roadmap, right? For the security, I didn't play it, right? Make sense? Talk about the exam and the questions with today homework one is due, right? I noticed I didn't check, right, before the class. I think at least half of the class at least already submitted. Regarding to the homework, I care about this work on it that's submitted. I don't care about which will be the format. Makes sense? Regarding handwriting, you can take the shortest time as long as you know the material. Makes sense? For the homework later I will put on the solution. I will not grade for it. So basically, it's your own responsibility to truly understand it. Make sense?
Yes.
So I didn't put the homework too much. The weight is not that high.
Okay.
Like 10%-ish. Make sense? I remember, right?
Yeah.
Compared to homework is really important. When you do your homework, basically you have to read the book, right? You find some kind of motivation to push you to read through the book, right? In order to find out the solution. Make sense? That's the basic objective of those homework. And as long as you actually understand that and actually know what's going on, that's the objective, right? Like my handwriting is worse, I don't care. If your handwriting is not that. Sammy, still not here? When? Not here, okay. Simon, because he missed the last time. Who is familiar with Simon? I need to send him an email. I do really care about you here because some of the subject you will not hear, you may have some kind of problem understanding. Okay. Guys, it's the time you think about what's covered, what we have learned so far, right? We have had 2 classes. Yes. Right? Yes. So basically, you guys think about during the chapter 1, what you have already done, right? Which section kind of really, if you ask yourself, what is the main concept covered in each section, you can get it. Make sense? No. For this section, I will later on, if you want to get corresponding video, you can find it, right? It's very clear. The YouTube video. It's really easy, right?
Yeah.
Just search for the author name, and it's organized very clearly. Yes. Okay? Only for the sense of the time. Time is not enough. Okay? So, for this security part, please watch by yourself. History is important, but consider the layering is one of the key concepts. Some of you watch the layering section, right? Some of you, right? I still, because we have a quiz, it's related to this section. We also have quiz, but I'm kind of giving you the quiz is related to which section is more important. It's just only for the sense of time. We still watch this together. After that, we have quiz. We'll call end of this chapter and move on to the chapter 2. Okay. Thank you.
Bless you.
Bless you.
Well, a pretty abstract problem. The internet is huge. It's got billions and billions, as the saying goes, of interacting pieces. We've got applications, we've got devices, we've got people at the edge, at the core, we've got links, we've got routers, we've got switches, hardware, software, and all of this interacts. And so the abstract problem that we want to address is how do we tackle the design and the discussion, and for us, the teaching and learning of such an incredibly complex system. And so in this section, we're going to do three things. We're going to introduce first the concept of architectural layering. And then we're going to look at the internet and look at the layers of the internet. And then finally, we're going to sharpen up our definition of what we mean by a packet. We sort of referred to it vaguely as data that's flowing around through the network. And we're going to want to be much more precise with our definitions here.
You ever see anything like this?
So let's begin with an analogy, since analogies are often useful. What's a complex system that you sometimes use or that you can think about? Well, how about airline travel or airline systems? That's an incredibly complex system. Think about it. There are planes, there are runways, there are towers, there's baggage claim, there's ticket counters, security, there are travelers, there's gate agents. This is a really complex system of a lot of interacting pieces. How might we actually define and discuss such a system? Well, you might think of it first as a series of steps. You buy a ticket, you go to the check-in counter, you're authenticated, you're starting your end-to-end journey. You check your bags, and now you and your bags, hopefully, are on your end-to-end journey. You go through security, you go to the gate, you wait, and then you board your plane. Your plane taxis, it takes off, it flies to the destination. There's a lot of routing of airplanes in between, you know. And when your plane arrives at the gate, you do these steps in reverse. You've completed your end-to-end journey. So this is helpful in one sense, in that we've broken down the trip into smaller pieces, but we want to be even a little more abstract here. We want to think horizontally. There's a function on the takeoff side and a related function on the landing side that together provide and implement a service. Delivery of your plane from source to destination, for example, or at a higher level, the delivery of you from an airport entrance to an airport exit. There are functions on the takeoff side and the landing side that together provide that service. And to implement that service, they rely on the services of the lower layers in the stack. Well, let's step back and ask ourselves, what's the advantage of this layered way of thinking, of having a layered architecture? Well, really there are two advantages. First of all, this explicit structure that we have shows the different pieces of the system and their relationship to each other. So we've got a very clear reference model for talking about the system pieces and how they interact with each other. And secondly, from an implementation point of view, we've really modularized the design. Think about a layer, right? The layer takes information in the internet from above, uses the services of the layer below to implement its own service. So if we make a change to the system, we change how a service is implemented, but keep the service interfaces the same, we've localized the changes. Think about the airline analogy that we looked at. If we change how the gate agent actually functions, well, that doesn't necessarily affect ticketing or baggage or how planes take off. So we've got that modularization that helps us with implementation, with maintenance over time. Well, the internet is clearly probably the largest and most complex human system ever engineered. Does the internet have a layered architecture? Well, of course it does. Otherwise, we wouldn't be talking about it here. So let's take a look. The internet architecture has 5 layers: the application layer, the transport layer, the network layer, the link layer, and the physical layer. The application layer includes the application layer protocols that control the sending and receiving of messages among the distributed pieces of the application. We'll cover the application layer first, since we're taking a top-down approach in this course. And we'll use this internet protocol stack here to actually provide the structure for our course. Another advantage to a layered architecture. We'll start at the top with the application layer and then work our way down. The transport layer transports application layer messages from one process to another. We saw earlier that packets could be lost along the way, for example, in router buffers. So perhaps the transport service has no reliability guarantee, or perhaps the transport layer implements a reliable data transfer service on top of a network service that can lose packets. That's what the Internet's TCP protocol does. The network layer transports data from one end device or host to another, maybe reliably, maybe not, depends on the service model. The network layer of the Internet does not provide reliable transport host-to-host service. Its service model is called best effort service, which means, hey, we'll do our best, but we make no guarantees. And you should note that there's a subtle difference here between host-to-host transfer, which is done at the network layer, and process-to-process transfer, which is done at the transport layer. The link layer transfers data between two network devices that are at either ends of the same communication link, and the physical layer controls the sending of bits into this link. Well, we've talked many times about the notion of exchanging data, and now it's time to be much more precise about that. And let's start at the application layer. At the application layer, we say that the distributed pieces of the application exchange messages with each other. So at the application layer, the unit of data, sometimes called a protocol data unit, that entities exchange is known as a message. Now, at the transport layer, we've seen that these messages are now exchanged by the transport layer from one part of the network to the other. What the transport layer will then do is take a message from the application layer and include some additional information with that message to create a new data unit, a new protocol data unit known as a transport layer segment. And this segment is the unit of data that's exchanged between entities at the transport layer. What information is included in the segment along with that application layer message? Well, some information is going to be needed to identify the process to which the message is going to be delivered at the destination, since there might be many processes running there. In the case of a transport layer protocol like TCP that implements reliable data transfer, we'll need to include a lot of information in the segment to actually implement that reliable data transfer service. The process of taking a data unit from a higher layer, adding information to create this new data unit, this new protocol data unit at another layer, is called encapsulation. Encapsulation happens everywhere in the Internet, and so it's going to be a really important concept for us to get down. A network layer protocol encapsulates the transport layer segment and adds its own network layer header information H sub n to create a network layer datagram. The datagram is the protocol data unit that's used at the network layer, and the header H of n is used by the network layer protocol to implement whatever its network layer service is. We'll see, for example, that in the Internet's IP protocol, the IP address of the sending and receiving hosts are contained in the network layer header. And the link layer similarly encapsulates the network layer datagram and adds its own link layer information. The protocol data unit transferred between the link layer sender and the link layer receiver is known as a frame. Now let's focus on the messages, the segments, the datagrams, and the frames and their headers. Well, we've been thinking horizontally in terms of layers and vertically in terms of data flowing down and up the protocol stack, and that's animated here. And so we see here data flowing down the stack, across, and then back up the stack on the other side. And as data is flowing down the stack, headers are progressively being added to create a segment, and then a datagram, and then a frame, and then going across the wire. And then as data flows up the stack, those headers are progressively read, acted upon, and then removed as data flows up the stack. So this is a really important slide, and you want to make sure you've got a good handle on this idea of encapsulation and data flowing down a stack and then back up a stack again. And now let's take the end-to-end view as an application layer message starts its journey at an application layer process at the source and makes its way to an application layer process at the destination. And as you watch this animation, look for two things in particular. First of all, pay attention to what's happening with the headers at each layer in the protocol stack. And secondly, as you do that, you'll note that deeper within the network, the switches and the routers only implement the lower layers of the protocol stack. That's because their job is to only forward frames and datagrams. They don't have to operate on the higher level transport layer segments or application level message inside the datagram or frame. Well, we've covered some really important conceptual ideas in this section. We talked about the general notion of layering in an architecture. We looked at the internet architecture, and then we looked at the idea of encapsulation, taking information from a higher layer, wrapping a header around it to implement a service, and then passing that down to a lower layer. So we've covered a lot of important conceptual ideas here. Coming up next, we're going to take just a quick look at some of the threats that networks face.
As I also mentioned, this section is really important from the big picture concept. Makes sense? So in your mind, you need to ask you, we talk about the different layers, right? What are the different layers? In this video, we also only mention the 5 layers, right?
Yes.
Because that's possibly in reality what's happening there. If I ask you for the 5 layer and the OSI 7 layers difference, from history perspective, is the 5 layers. For the next section, talk about the history. I suggest you guys will watch yourself. Okay, like from the internet history point of view, the internet start from is from what DOD project. So that's basically these 5 layers is start from what implementation. So based on what's needed, they start implementing what kind of layers necessary. Make sense? For the IEEE OSI 7 layers, is what's happening there. History is a group of engineers, scientists sit together. So we need to make this happen. We need to design a network sleep, right? Based on what they are thinking. Okay, that's basically why in reality the 2 layers, the session, the presentation layers, is barely mentioned in reality. Makes sense? So that's why in this class we are more focused on those 5 layers instead of those 7 layers. Okay, so this is a quick summary for this section because this section is important. After this one, we will briefly discuss, we'll finalize chapter 1, move on to chapter 2. send your email. Tell your attendance is required. For anybody in attendance cannot be here regularly. There's some limit, like between certain deadlines, you can destroy this class, right? Without any W or any sign on your transcript. Attendance is mandatory required. That's my point. Okay. it's very easy to find all the authors' videos, right? If you check. Anyway, I just put that's 1.6 is security related. Please watch, just for the information. It's also important knowledge, but we will not play with you all the time. Okay. And the history section is the last section of this chapter. We just played the section in between, which is layer, because from conceptualized, layer is one of the essential concepts. You guys all that?
Yes.
Okay. We will quickly working together. Okay. That's the time if you have questions, we can quickly discuss. So, I emphasize the attendance. I also emphasize you guys attendance because during the class time, if you have any questions, I can answer. Makes sense? Of course, if you have any time later on, drop me an email. We can also set up like a Zoom meeting or something like that. It's all fine. Okay. And for the homework also, I think it's important. When you do your homework, it's a time you find, I'm still kind of not that clear. You will go back to the book to read. That's the part I really, that's the process. Okay, let's do this. Then, of course, towards eventually the grade is also related to the exam, right? When you do the quizzes, exam will be closely related to the quizzes we are doing here, homework we are doing here, and the examples typically when I'm teaching, I already put the emphasis like this concept is important. Makes sense? Those kind of concepts will very possibly, I'm teaching the class, I'm creating all the exam questions. Makes sense? That's in my head. So think about the probability what will be in the exam. Of course, it's worthwhile. I keep emphasizing. Make sense? Just for some of you, because in the morning I was in the hospital, so I didn't check my email, so I didn't see. Okay, let's do this. The layer part. This is question number 1, layer in the Internet property stack, right? This one is more like a definition for each layers, right? Makes sense? So the first one, we have 5 layers. Remember, throughout this class, we emphasize 5 layers, okay? First one, the protocol that's a part of a distributed network application. You will put on which one? Application layer. Right, from the perspective of different applications. Okay. Then transfer of data between one process and another process. This one you will give transport layer. Some of you, I think here quite a few come from computer science department, right? Then if you're related to the computer or operating system, it's related to different processes, right? Makes sense? Then think about it. Each time you have a different application which is associated with the process. Makes sense? Makes sense, guys? In that case, some of the terminology, sometimes we are saying host to host, process to process, or end to end. Seems similar, but the meaning is different. Makes sense? When we talk about the process to process, that's related to which layer? Transport layer. Can I say when we talk about process to process, it could be network layer emphasize? Could be? What is it? Oh, come on. Yes. When we talk about the process to process, the thing is, because this is a top-down approach, right? Yeah. We start from application layer, we move to transport, then network, then link, then physical layer, right? But still, during the introduction, I want to give you the big picture. This will help you understand a little bit. Think about it now. So far, you already know the IP address, right? Although we have version 4 and version 6, right? Makes sense? For the IP address, it should be associated with which layer? Network layer. Then, besides the IP address, you guys also heard about port number, right? Yes. For example, HTTP, that protocol typically is associated with port number. 8, right? So you guys already know it, right? Like you guys heard about it. port number, like for example, for DNS, port number, that's a number, but you know what's the port number, right? So when we talk about the port number, which is associated with which layer? Of course, from the computer science background, every time when you have a new application, the operating system needs to assign your port number. Make sense? This one was made out. But for the port number, this concept, this resources, which is associated with which layer? Transport layer. Make sense? So in that case, when I ask you, when we talk about the process to process or host to host, what do you think? What are the major differences? So sometimes think about it, you're living in a big house, right? That's your house, right?
Yeah.
And she also lives in a big house. For in each house or whatever, there are multiple persons living in there, right? If we send the author used that kind of an analogy. If you mail a letter to that house, to her, right? Mm-hmm. You need to put the address in there,
yeah.
Right? Sending address, receiving address, you're sending that to her, right? Yeah. You put the destination address there. So that address, exactly that house address should be associated with each concept in the network concept. Not network, more detailed. When we talk about what kind of IP address, right? Basically, when you try to send her mail, right? You need to put your home address there. You need to put her home address there.
Yeah.
So your home address is like your IP address. Yeah. And the destination is like destination IP address. Basically, when the mail receives that kind of a house, basically is equivalent to receive that address, right?
Yeah.
Then in that case, for each house, multiple persons could live in there.
Yeah.
That basically should be corresponding to who you are targeting to. Make sense?
Yeah.
Got it? That who part is related to process. Or if our network resources is related to different port number. Make sense, guys? Because then think about it. Some of you still keep checking your phone, right? When you're using your phone, when you're here, you're using Wi-Fi to access the internet, right? In that case, you will get an IP address. Make sense? This way you can access the internet. Then when you're using your phone, you're using your computer, you're doing multiple applications. Those multiple applications is similar to multiple persons living in that the box, right?
Yes.
Make sense, guys? I just hope you understand basically layer to layers, those kind of mapping. So we only say I received the targeted address, but later on when you move up to those kind of layers, they need to tell which specific application you're talking to. Make sense? Only going to those addresses is not enough, because each computer have a multiple function, right? Think about every day you're doing. You're checking the news. Like my younger one, she's working, but at the same time she knows everything. That means when she's working, she also check out the news, right? Later come here, she knows everything. That's basically you guys are checking your social network, you're checking the news, you might check your Instagram, whatever. Multiple applications you're running on your device. And each application, they should have a corresponding process, which is corresponding port number. Make sense? And those are still stay in the same device, which is IP address. In that sense, you kind of know IP address, network layer, port number, and the process is transport layer. Make sense? Yeah. Then for each IP address, you have multiple applications. In that sense, think about the information, multiplex, right? Eventually send it out. When you reach the destination, you need to distribute your letter, right? This is to who, and who. That's the demultiplexing process. Make sense, guys? Okay. That's it. I don't know this computer is interesting. Okay, so in that practice to transfer data between one process to another, this would be transfer layer, right?
Yes.
Next one, delivery of a datagram from a source host to a destination host. That would be network layer. That's basically like you mail your physical letter from one house to another, one address to another address. Make sense? Okay. And the transfer data between neighboring network devices would be link layer. And the transfer bit into and out of a transmission media physical layer. Okay. So this is basically, if I ask you what would be basic function of each layer, similar case, right? It's just a multiple choice case. Okay, next one. What's the packet really? So for the last class, we emphasized, you guys all know the internet is based on packet switching, right? When we talk about packet, we generally call it packet, but in each layer, they might have different names. We generally call it packet, right? So application layer, typically we call it what? Message. Transport layer, segment. And the network layer, datagram. And the link layer, frame. And the physical layer, eventually 0 and out, 0 1, out, bit, right? And then question number 3, the protocol headers. This is also actually really important. Guys, remember when we play with, you guys remember last class we played with the different delays, right? You guys still remember each nodal delay include how many different delays in there? 4. Each node we will have a, why is the people something low? We have a transmission delay, right? What else? Processing delay. Queuing delay. Propagation delay. All of you know the basic understanding, right? Remember when one of the example I showed, we have a big, like a big file sent from one destination to another destination. Roughly how long it will take, right? You guys remember? Do you guys remember I mentioned it's an estimate, right? Do you guys remember? In reality, when you send a big chunk of file from the source to destination, typically what do you need to do? You need to break into smaller chunk, right? From the smaller chunk, that's your original information, like this information. The application is called message, right? Then this packet need to move down the layers, right? When you move down to the transport layer, they need to, from application layer, they also have the original message. They also have the headers too. Okay, application header, that's this. You think of this is getting bigger, right? Added a new header. The move down to the transport layer, everything is still there, but you need to add a new header before that. Make sense? That's the transport layer header. Then everything you need to move down to the network layer. You need to add the network layer header. Basically, then move down to the link layer. You add the corresponding link layer based on whatever you have. So basic original packages is this big. You need to add the header there.
Yeah.
Since it's getting bigger and bigger. Point here, so when you're actually doing this, think about the original file is this big. When you break down the chunks, you add all those headers. This one, it's a cost, right? When you add transmission, it's bigger than those. At that time, we haven't talked about this. That's basically just an estimate. Make sense? Okay, that's all the header information, right? Then that's basically this concept from application all the way adding the headers, eventually sending out 0. This concept is called what?
Encapsulation.
And on the destination, it's a reverse project, right? Make sense, guys? Now, because you're in here, right? Now you know you'll keep adding the headers, right? Guys?
Yes.
Now, we already mentioned like what is port number, the IP address, right? Make sense? You also heard when we talk about the address, we have an IP address. We also have what?
Of
we have other address too, right? MAC address, right? Makes sense. All the information. Think about those. Now, then you kind of know when we move down, you need to add the corresponding header, right? So now you can imagine in your transport layer header, what kind of information should be included in the header? I mean transport layer. Transport layer. Transport layer port number should be in there, not the IP address, because transport layer, the IP address is not the main function in that layer. Make sense? When you move down to the network layer, at the network layer header, what will be in the header field? IP address, both source IP and destination IP. Make sense? Then think again, right? When you move down to the link layer, right? What information is that? The MAC address, because eventually the MAC address is what we will express our devices. The IP address is what? Basically, you're assigned to code subject to change, not like your MAC address. Make sense? Okay. You kind of group all those information together. You kind of know in each layer associated with corresponding headers there. Then in the header, then you have multiple fields in there, right? Those fields need to include all the related functionalities related to that header. Make sense? Just the thought. Later on, when we talk about the protocol, you will add those information in there. Makes sense, right? Okay, now after this is explained, this should be easy, right? This one is showing a frame at the link layer, basically, right? Include all of this is. I don't know if this computer, I don't know what's happening. Okay. So basically what's asking is there are 3 header fields shown here. Match the name of the header with a header label shown in the figure, right? So in that case, H1 should be, H3 should be
Transport.
H3 should be no, the link layer. Transport.
It's transport.
Basically, it's like adding. Okay, depends on. Basically, I'm checking is in that case they already says message. Sometimes you also have the application header, right? In that case, they didn't mention that part. Okay, anyway. So H1 would be link layer. H2 would be network layer. H3 is transport layer. Basically, that's the original message. Depending on which protocol you're using, actually the application header already included that message in this figure. Make sense? You need to add the transport layer first, then later on add the network layer, then add the link layer. In the physical layer, when you send it out, still there is some kind of physical layer related information there, right? Like the CRC, the error correction, like when to start, when to end. Makes sense? In that case, we are not talking. In this case, we are not talking about those. Okay, next one. The encapsulation. Which one did you pick? What is encapsulation, guys? That's number 4. So C, everybody agree is a C?
Yes.
Do you have other choice? You guys are okay, right?
Yes.
It is C. Okay, then moving on. The reason I put the security part in the video, in the e-course, just in case you guys can see, just for information, watch those sections, okay? Here, we just quickly get the answer out. First one, specialized middle box filtering or blocking traffic, inspecting packet contents inspection would be firewall. Provide the confidentiality by encoding contents.
Encryption.
encryption, used to detect the tempering change of message content and to identify the originator of a message.
Digital signature.
Digital signature, like a DocuSign, right? Limiting use of resource and capacity to giving users.
Access control.
Access control, providing you or who you say you are.
Authentication.
Authentication. Okay, so pretty good. Okay, so this will be done.
What answers do you get for this one?
You guys can keep it. Okay, you can keep it later on to prepare for your future exams. Okay, like I mentioned, only the time when I try to get it is based on my field, right? If, for example, I don't know why
Okay.
the attendance is really bad, I will decide I will try the quiz, give a little bit higher rate to give us some reward to those who show up. Okay. Now we just quickly finish this chapter. I think you guys should have a better understanding regarding the layers, right? Makes sense? I don't like this analogy, the airplane, but anyway. But at least it's kind of process. This is just for some of your students. Typically, when you enter class, when you learn computer networks, the ISO, ISI reference model is still there. Just notice the difference in presentation section there. Okay, just for your information. Typically, we more emphasize at this layer. Okay, but the internet not goes back. And then this one is actually really important. Really important. Okay, I think you guys already understand from the original message. You add the onion layers, right? They send it out, right? At the receiving side, you remove the onion layers. Make sense? For link layer, you will check the link layer's header information. Okay? Then move to network layer. You will check the network layer header information. Then decide to move to the transport layer, right? For the two end-to-end, you should understand, right? So some of you will ask, typically we will say, so remember we talk about the switch and the router's difference, right? Talk about for network layer, what's the major function of the network layer? Routing and
IP address.
forwarding. I forgot about the quiz question. Forwarding, right? Routing is a global kind of, remember? That's one of the two main functions for the network layer, right?
Yes.
Then we also sometimes say router only run up to what? Network layer, right?
Yes.
It makes, sometimes we say that, right? Then some of you may ask me, so for routers, it has its own operating system, have everything, right? Of course, they have application transfer and everything here. It's complicated design, right? What do you mean that routers only runs through the network layer? Guys, think about those. Then for the switch, when we talk about the difference of switch and routing, right? Switch basically only run to what? The link layer, right? Because switch mainly happens in the local area network, right? Make sense? So from this one, everything is there. What does it mean for router only run to the network layer? Israel. So basically think about those, right? Of course, routers has its own lots of software. It's complicated. They have all the information. They have their applications, transport, everything, right? And from network concept, network functionality-wise, it only runs through the network layer. Also, you need to ask yourself the network edge and the core concept. But the network core mainly is compromise all kinds of routers, help you to pass on those kind of data packets, right? Make sense? The question I'm asking you is when the packet is coming to router, what's happening here? When the packet comes to router, see, in this router, we didn't put all 5 layers here. Make sense? We only put the physical link and the network layer link. Similar concept is happening. When this zeros one coming in, the physical layer will decide when to end, when to start, when to end. This is physical layer. They move up to the link layer. The link layer will also check the link's header, the frame header. Then move up to the network layer. In that case, the router will check the information in the network header. Okay, make sense? Then in that case, the router will make a decision. So they will check, they can see what's in the network header, right? What will be in the network header? The source IP and destination IP, right? Make sense? That belongs to network layer. They will check the network, the destination IP part. If then the router know which network layer he is settled in, right? Make sense? If they check destination IP is what? Remember they have a forwarding table, right? Based on the destination IP, they will know whether it is already reached this local destination network or they still need to send it out. Make sense? Make sense? But they need to check the information to make the decision. If they check, remember they have the forwarding table, everything, based on this destination IP address, they will make those decisions. Should we forward it out to which port? Make sense? That's what's in there. When they, based on those information, make that decision, we already know how to send, what will be next, how, right? Make sense? In that case, what they need to do? They need to repackage the whole thing, right? Right? They may need to change a few fields in the network header, put a new network header. Majority information is still the same, but a few fields may change. Make sense? Then, when they move down to the link layer, they need to add the new link layer header there. In the link layer header, what will be in there? Link layer, basically, what's the next hub's physical MAC address will be in the new link layer header. That's why they can physically send it out. Make sense now? That's what means in this here. Router, they still handle those when they pass it through, but they don't care. The packet is detailed information in the packets. Whether it's some browsing information or email or DNS, they don't care at all. They only care the information related to network layers. They only check what is the destination, the network layer header. Then make the corresponding decision. Then repack it, resend it out, right? Got it? Similarly, switch is more local. Only check the local information, okay? Only to the link layer. Of course, switch. This is a slide I hope you guys actually think it through, okay? So the encapsulation concept, added transport layer header, everything, added another header, right? Everything, right? Keep adding. Let's add the frame header. Then send it out. Here is see everything.